Section 4.1, commutative, associative, and distributive laws. This is stuff I know you know. You just might not know the names for it. All right, so let's talk about commutative law first. Commutative laws, there are two of them. Number one says A plus B equals B plus A. No shock there. 5 plus 2 is the same as 2 plus 5. I think you all knew that. You might just not have known it was called the commutative law, which I spelled wrong. There's two M's in commutative. And 2, A times B equals B times A. Again, 3 times 4 is the same as 4 times 3. Again, I'm sure you knew that too. Second law is associative. Oh, well, notice something important. This doesn't work for subtraction and it doesn't work for division. For example, 8 minus 3 is not the same as 3 minus 8. One's positive 5, one's negative 5. And you can pick almost any two numbers and try the same thing with division, and you'll find it doesn't work either. But one thing you can do this. If I have 8 minus 3, I can think of 8 minus 3 as 8 plus negative 3, and then I can switch the order and write it as negative 3 plus 8. And we'll use that, and let me show you how we're going to use that. We're not going to deal with just numbers, of course. Most of the time we're going to have letters. So I might have something like 4 minus 6x. And usually when we have expressions like this, we like the x's to come first. So we would think of this as 4 plus negative 6x, and then we would write it as negative 6x plus 4. Now, in general, that middle step I'm not going to expect you to write down. If you have 5 minus 2x, I'm going to expect you to just switch the order. And when you switch the order, all you do is keep the signs with the right ones. The negative 2x gets a negative, so that one's a negative 2x. And the 5 was positive, so that one stays positive. All right, associative laws. Again, there are two. One for multiplication, one for division. Associative laws say A plus B plus C is A plus B plus C. So it says you can change parentheses. You can do the parentheses in either spot. And the same thing works for multiplication. A times BC is AB times C. And where we use this, we tend to use the multiplication one more. Let me show you what I mean. Let's say I have 8 times 3x. What this really means is 8 times 3 times x. We don't put the multiplication sign in between, and we usually don't put the parentheses. But what the associative property says I can do is I can switch the order, switch the grouping, and I can write 8 times 3x, which is 24, of course, x. All right, so again, when you do this, I'm not going to really expect to see all these intermediary steps. If you have something like 5 times 6x, I'm going to expect you to just write it as 30x. Last one is called the distributive laws. And there are two of these also, but they're very, very similar. If I have A times B plus C, that's the same as AB plus AC. Or if I have A times B minus C, that's AB minus AC. And these really make sense when you do them with letters. They don't make much sense with just numbers. Let's say we had 5 times 2x minus 3. Well, what the distributive property tells me is that I can take that 5 and distribute it and multiply by each one. So I could write this as 5 times 2x minus 5 times 3. I get to just multiply each term. That becomes 10x minus 15. And again, I don't really expect to see that intermediary step. If I give you 4 times 8x plus 2, I would expect you to just write 32x plus 8. One thing to watch out for is do watch out for negatives. Let's say I had a negative 3 times 2x minus 8. Got to be careful now. You got to distribute the minus 3 through. So minus 3 times 2x would be negative 6x. And then minus 3 times minus 8, you're multiplying two negatives, you get a positive. That would be positive 24. So watch out for that. That's an easy mistake to make. It's easy to write minus 6x minus 24 there, but it really needs to be plus. And kind of the last little tricky thing you'll see, sometimes you just see a minus sign outside the brackets. Minus 4x minus 7, for example. Well, this minus here really means, we're just a little bit lazy in math sometimes, it really means a minus 1 times 4x minus 7. So if you see just a minus sign out there, think of it as a minus 1 and simply distribute it through. Minus 4x plus 7. Now, what are all these laws good for? Well, we'll really see more of that in section 4.2. What we're going to do in section 4.2 is we're going to have expressions. I've written a lot of expressions on the page here. And we're going to use these properties to combine our expressions. Let me just give you a brief example. Let's say I had 5x plus 2 minus 3x plus 7. And you will do a little bit of this in section 4.1. All we really do is we use the commutative property as needed, sometimes the associative property. So we write this as 5x minus 3x plus 2 plus 7. So notice all I did. I used the commutative property. I interchanged the 2 with the negative 3x, making sure I kept my signs. The 2 was positive, the 2 stayed positive. The negative 3x was negative, it stayed negative. And then we use the associative property to say, well, you know, we can group these things if we wish. So we group them like so. 5x minus 3x is 2x, and 2 plus 7 is 9. And again, when you're doing this on your homework, I don't necessarily expect to see all of these steps. I just want to show you why we're talking about the commutative law and the associative law and what they're good for. I would expect that you could go from the original problem right to the last step for this one without showing any work. I would expect if I gave you this on a quiz or a test, you would simply write 2x plus 9. You don't really need to show me that work.